Hi, today we're going to solve 2016 AP Calculus AB question number 1. So it's a calculator active question, and you do need a calculator here quite a bit. So what we have here, we have some function r of t. Well, first of all, we have a function, water is being pumped into a tank at the rate which is modeled by this, liters per hour. Please note this is the rate. T is measured in hours. Water is removed from the tank at the rate modeled by r of t, liters per hour, where r is differentiable and decreasing on the interval from 0 to 8. We have some selected values of r shown in the table, and when t equals 0, there are 50,000 liters of water in the tank. So the first question is estimate r prime of 2. Fairly typical question. R prime of 2, we have the value of r at 1, the value of r at 3. So all you need to do is approximate that using a difference quotient. So part A, r prime of 2, it can be approximated as r of 3 minus r of 1 divided by 3 minus 1, which is 950 minus 1190 divided by 2. And it's a calculator active question. So we are going to, you don't really have to simplify from here, but we're trying to be good. And divided by 2, this is going to be negative 120. So negative 120. Important thing, indicate units of measure. So how do we determine what they are? R was measured in liters per hour. Since we're dividing by hours, it's going to be liters per hour per hour. Okay, and that's this question. Pretty easy. Question B. Use the left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed from the tank. And then the question is this going to be an overestimate or an underestimate? Let's approximate this first. So this is how I like to represent this. We're going to do the left Riemann sum. So everything's going to be going to the left, right? On each interval. So this is going to be the width, this is the height. So and you're going to have 4 of them, right? So the height is 1340, the width is 1. You're going from 0 to 1. So water removed, it's approximately going to equal to 1 times 1340 plus. The second interval is going to be from 1 to 3, that's 2. Left end is 1190 plus. From 3 to 6 is 3. Left end 950 plus. From 6 to 8 is 2. Left end 740. Okay, so we can plug it all in the calculator. We don't need to do, well, we actually don't even need to simplify it, but we'll do it anyway. 1340 plus 2 times 1190 plus 3 times 950 plus 2 times 740, and we are getting 8,050 gallons, right? Okay, that's done. But now the question is this an underestimate or an overestimate? And we also need to justify our answer. Let's see what information is relevant here. It tells us that the rate is removed by a function r which is decreasing. If the function is decreasing, the left Riemann sum is always going to be an overestimate. So you don't need to go into too many details here. You can just say it is an overestimate because r of t is decreasing. That will be enough. Okay? Part C. Now part C, we're going to have to now use the other function. So what are we trying to do here? We want to find the total amount of water in the tank at the end of 8 hours. So what do we have? We have the amount of, excuse me, we have the amount that was there initially, 50,000 liters. Total water is going to be 50,000. Then we have 8,050 gallons that was removed. So minus, oops, I'm sorry, 8,050. 8,050 gallons that was removed, and then plus the water is going to be pumped into the tank. So this is, since we're given the rate at which it's pumped, we're going to have an integral from 0 to 8 of W of t dt. And because that function, it's a calculator active question, this function is easy enough to handle, so we can, this is the only question, this is the only part where you actually need to use this function. I'm just gonna type it all in to the calculator now. Okay, so we have 50,000 minus 8,050 plus, we gotta go to math, I'm sorry, integration is here somewhere, integral, very carefully we're gonna enter our function, 2000 e to the power negative, remember we're never going to use t, we're always going to use x, so negative x squared, please don't put parentheses around negative x, divided by 20, this is the function, comma, the variable of integration, comma 0, comma 8. Okay? Let the calculator do its work, and we are going to end up with 49,786 gallons. It does ask you to round to the nearest liter. So 49,786 liters. Okay. And the last question here is, this one is a little tricky. From 0 to 8, is there a time t at which the rate at which the water is pumped into a tank is the same as the rate at which the water is removed from the tank? And explain why not. So, all we need to do is determine this. If we take the rate of change of W, so W of 8 minus R of 8, if you can calculate this, it's actually going to give you, well, we know that R of 8 is 7,000, and you can estimate the value of W of 8. So let's see, W of 8 will be 2,000 times e to the power negative 8 squared divided by 2 by 20, right? And then we're going to do minus R of 8, which is going to be 700. It's going to give us a negative value. So this one's negative. If you do W of 0 minus R of 0, that's going to give you positive. Right? So this is the difference between the rates. We know that W of t minus R of t is continuous. We know that because both W and R are continuous function. So since W of 8 minus R of 8 is negative, and W of 0 minus R of 0 is positive, then by the by the intermediate value theorem, there must be some value of t on the interval between 0 and 8, where w of 8 minus r of 8 is going to equal 0, meaning w of 8 is going to equal to w of t, r of t. W of t is going to equal to r of t. Okay, so yes. And that's all of it. Hope this helps.